in case of acid, stable conjugate base will give a stronger acid, and in case of base, the ease of donation or availability of lone pair will be the determinant factor. So welcome back to our second class. This class we will be discussing the basics of acids and bases and other reaction intermediates. So before going into the discussion, let's have a quick recap of what is acids and what is base and how we determine their strength. So basically what to do, well, acid is actually something that gets dissociated like this, that is H plus and A minus. Now this is a reversible reaction and it depends on the stability of the A minus. That is, if the A minus is stable, then the reaction will go to the forward direction and the acid will be stronger, and if A minus is weak, hence acid will be weaker. So the basis of acidic strength is the stability of the conjugate base, that means the A minus. In case of base, the base reacts like that. The base reacts with H plus to give BH plus. Now generally the base attacks the H plus with its lone pair. So the availability of lone pair is the main factor of basic strength. The compound which can easily donate an electron or a pair of electron, I might say, will be a stronger base. So in case of acid, stable conjugate base will give a stronger acid, and in case of base, the ease of donation or availability of lone pair will be the determinant factor. So now let's go to the problems. So here is the question 1, and what it said? It said that identify the most acidic compound in A and B and the most basic compound in C and D. So there's a quick tips like that this say this is the structure of an acid. Now this hydrogen is acidic and this hydrogen is attached with molecule or atom A. Now if B is providing electron donating effect, or that is if B is electron donating group, the acid will be weakened. But in same compound, if B is electron withdrawing group, so acid will be strong. So here you can see that this group is the acidic group, and in this case CH3 is giving plus I effect. So this will be weaker acid. So the strength of acidity will be like this for in case of A. That means 1 will be the most acidic compound in A. So option A may be the answer, or option D may be the answer. Option B and option C is not correct. So let's check option A. A1, B2. A1, B2. It is similar. C1, C1. Up to C, option A and option D is similar. Now option D has D equals to 1 and option A has D equals to 2. Now if we can only check D, we will get our desired answer. So how will we check? It said most basic in C and D. So we have to compare the basic strength. Now quick tips. This is a basic group and this has a group. If it donates electron, the base will be strong, and if they withdraw electron, the base will be weak. So CH3 group is donating electron, and hence this will be most basic, as we have already mentioned here. So in this case, for D, 2 will be the correct choice. So option A is our right answer in this question. So we do not have to check B and C. It will take time, but we will not check this, because we have, if we check A and check the answers, we will get our answer. We do not have to check B and C. It will save our time. So this will be the approach if this type of problem comes in JEE Mains. Come to the next problem. This is kind of similar. It said that in given pairs, in which pair second compound is more acidic than first. So we have to determine which of these 4 options, the second one is more acidic than first one. In this case, that is pair CH2 NO2. These two are electron withdrawing group, and hence C is acidic. But there is no electron withdrawing group present in CH2, CH3, that is in ethane. Hence the acidity is first one greater than second one. So this is not the answer. Come to the second option. Similar case, this group attracts electron, also cyanide attracts electrons, but there is no such group. Only this group attracts electron from the CH3. So this CH2 will be more acidic than this CH3. Hence the acidity order will be like this, and this is also not the answer. In this compound, this is the electron withdrawing group, and this will withdraw electron from this one. So obviously in these cases, this will be the strongest acid. So in all the 3 options, the first one is the stronger acid than the second one. But in case of D, if we draw the structure like this, CH3 group provides electron, but there are no such positive inductive effect or electron donating group present in, actually this group is not present here, so no such positive effect. So in this case, this will be the stronger, as this one has electron donating group, and electron donating group weakens the acid. So in this case, the second one will be the stronger than the first one. So this will be our answer as per our condition. So always remember that you may know a lot of things about any questions or any particular topic, but to score good marks or good percentile in JEE Mains, you have to be smart. So no alternative of being smart. To score good marks, you have to be smart, and that's is what we are gonna learn. Come to the next question. This particular question is very interesting to me. It said that Et3N and this compound, in these 2 compounds, compare their basic strength. Hence we can say we have to compare their basic strength. Now we have already mentioned that this is a basic group, and this group, if this group is electron withdrawing group, the base is weakened. But if this group or the adjacent group donates electron, the base is strong. But we cannot determine by this. We cannot apply this topic or tactics in this question. So how will we solve this? Now we have already discussed that the basicity of a compound also depends on the availability or the ease of donation. Now this 3-ethyl group is free. They can rotate around the nitrogen as much as they want. So if the 3-methyl group are present like that around the nitrogen, there will be no position of nitrogen to donate the electron. That means all the doorways are blocked, so the lone pair cannot get out. But in these 2 cases, the alkyl groups are tied behind the nitrogen. So one side of the nitrogen is always open and they can easily donate electrons. So one will be the weakest. Now if we compare 2 and 3, there is a second nitrogen in compound 3, and this second nitrogen will exert minus I effect on the first nitrogen. So an electron withdrawing group present which will weaken the base, but there is no such group present to weaken the base. So 2 will be stronger than 3 and 1 will be the weakest. So 2 greater than 3 greater than 1 will be our answer, which comes in option C. So option C will be our answer. Time for next problem. This said the which side 1 or 2, between 1 and 2 and between 3 and 4, which side will be the preferred site for protonation. Now for protonation we need lone pair of electrons, so more density of electron will be the preferred site for protonation. So let's compare compound 1. So CH3, C double bond of NH, CH3. This is the case. So this lone pair of nitrogen will go on resonance to form a resonating structure like this, O minus N plus. So now we are seeing that this nitrogen has already donated its lone pair and it does not have any lone pair in this canonical structure, but the oxygen has gained a negative charge or an extra pair of electron. So between 1 and 2 it is very clear that due to this low resonance, the lone pair of nitrogen will not be readily available for protonation, and electron density on oxygen is greater. So 1 will be the preferred site for protonation in case of compound 1. So 1 will be the preferred site. Now come to this point. This nitrogen, that is the nitrogen on the pyridine ring, cannot take part in resonance. As we know, the pyridine ring, all the p orbital is perpendicular to the ring, but the lone pair on the nitrogen is on the plane of the ring, so it cannot delocalize with the ring p orbitals. In this case, this lone pair can never be take part in the resonance, but the adjacent nitrogen, which is like there, and here is the nitrogen, this nitrogen can easily donate electron to increase the electron density on the pyridine nitrogen. This will be negative, this will be positive. Hence this nitrogen, that is nitrogen number 3, will have more electron density and lone pair availability will also be more. Hence 3 will be a preferred site for compound 2. So 1 and 3 will be the preferred site, and this option comes in option A. So option A is the answer. It's very simple. You just have to keep the points in mind, nothing else. So the last question, it is from basically intermediates. So we are asked that the most stable canonical structure in between 3. So there are a lot of factors which determines the stability of a canonical structure. The most important point of stability of canonical structure is the number of covalent bonds. That is, more the number of bond or covalent bond, more stable will be the canonical structure. So if we count the number of covalent bond, this will be the easiest way to do it. So this one has the 7 covalent bond, 1, 2, 3, 4, 5, 6, 7. This one also 1, 2, 3, 4, 5, 6, 7. This one 1, 2, 3, 4, 5, 6, 7, 8. 8 covalent bond. So 3 will be our correct answer. We can also explain it like that. In this compound 1, this carbon does not have its octet filled up. This carbon has 6 electrons. Similarly, this carbon also has 6 electrons. But in this compound tree, all atoms have their octet filled up. Hence, filled up octet will produce stable compound. So, 3 will be our correct answer. So, we can explain it any way we want. So, I hope you liked or you have understood what I am trying to make you understand, and I'm sure this will help you a lot. So, thank you everyone, and all the best for the exams.